Hi and welcome to a new 3DE4 tutorial. This video demonstrates how to solve a quite tricky task. Reconstructing motion capture with a moving camera filmed with an anamorphic lens. Oh yes, that really sounds like trouble. But of course, surrendering is not in our vocabulary, so we will solve all these troublemakers in two parts. Part 1 focuses on setting up the project and tracking all data, including some tips and tricks considering tracking and organizing points within a motion capture project. Part 2 is all about camera parameters for reconstructing the shot. Well, we have a lot to do. Let's get started. Select the camera, then folder mocap of the 3DE4 tutorial folder. Folder footage contains all shots we need. For now, let's import shot 0355. Next, we obviously have to adjust the camera's lens parameters. Luckily, we do know that an ISO anamorphic lens was used during filming, so pixel aspect is 1.5, fill back height is 1.118 centimeters, and perimeter focal length should be set to 35 millimeters. Finally, let's name this lens ISO 35 millimeters. Great! Now, export all images to a buffer compression file and play the sequence. We see a camera moving unsteadily around a young actress with markers across her face, obviously speaking something intimidating. In the background, we see a green wall covered with background markers. At the beginning and end of the shot, a hand holding a virtual clapperboard is visible. Okay, let's continue with the setup. As seen before, there is more footage from two witness cameras. So, create two additional cameras, and with the first new camera selected, import sequence witness cam left found again in folder footage. We quickly notice this shot was not filmed with an anamorphic lens, so we have to create a new lens for this camera. Which will be named witness left. Here we also know the basic parameters. Fill back height is 1.253 centimeters and focal length is 18 millimeters. Assigning this lens to our left witness cam is done quickly by right-clicking on the camera, then select Modify Lens Witness Left. The shot looks right again. Again, export all images to a buffer compression file. Then have a look at the sequence. It is the exact same set. Actress, green wall, markers, virtual clapperboard. Everything's there, just seen from a different angle. Alright, last step of importing. Repeat everything for sequence witness right. Import footage. Create a new lens. Name it witness right, as well as edit film back height and focal length. Assign this lens. Export compression file. Play. Same story, again a different angle. Okay, now let's have a closer look at the beginnings of each shot. To work with these shots properly, it is necessary they are synchronized, therefore start with the same frame. And since it is highly unlikely all three of them are doing this right out of the folder, we have to do this manually. So let's find a good frame. Basically any frame is good. Just find a frame, in our case a timecode number is the best choice, that can be identified easily within all three sequences. So, for the main camera, let's skip to frame 44. Here, The timecode shows 3 minutes, 56 seconds and 0 frames. Looks good to be identified in the other cams as well. So this will be our new frame 1. Editing the duration of a shot is done in tab Camera, more precisely with parameters Start and End. Obviously, we have to set parameter Start to which number? The start and end numbers are set automatically depending on the digits within the suffixes in the file name of the imported sequence. So the file number of the current sequence here and the frame numbers within the file name don't necessarily have to match. Luckily, the full file name of every frame is displayed in 3D's status bar. So we see our start number is 43. Here we go. Previous frame 44 is now frame 1. Again, we have to repeat this for the other 2 cameras. In camera witness left, we find our chosen timecode number at frame 84. So the new start frame is, like seen in the status bar, frame 83. Camera witness right now starts with 79. By the way, a quick tip. If cameras have to be selected quite often, like in this project, this can be done much quicker using Python script setNextSequenceCamera, more precisely via its shortcut. Next, here we go. Easy and fast. Last thing, we should make sure every shot runs with the same FPS rate. In our case, 24. Quite good so far. After syncing all 3 sequences, the cameras within the project have to be synced as well. Synced cameras do not only tell 3DEqualizer's calc core the relation between them, considering the primary and secondary camera, it also syncs the frame slider within 3DE4. This makes sure that we always see the same frame when switching cameras, which increases the comfort of tracking the same feature in different cameras a trillion times. We will get to that later in this video. The options for syncing can be found within tab Camera, Synchronization. Let's select our main camera, then set it to the primary synchronization camera. Since the camera is moving, parameter constraints is left to none. Next, both other cameras are our witness cameras, hence can be selected together. And set to the secondary synchronization camera. Here, both cameras are locked throughout the entire sequence, so set constraints to camera position and rotation is fixed. Great, let's see if the syncing worked. Select the camera and drag the frame slider to a random frame. Next, select the other cameras and we see their frame slider remained at the same frame. Marvelous! To close this chapter, we should crop all 3 sequences to the same duration. The main camera shot is shorter than those of the witness cams. In our case, we do not need any information these additional frames contain, so set both witness cams durations to the same 259 frames. The quickest way is select the main cam, then go to the last frame. Now select the next camera. Again, we use the trick with a file name in 3D4 status bar for finding out which number belongs in text field of parameter end. For witness left, it is 341. Witness right ends with frame 337. Perfect, we got it. Everything's set up. Okay, time for the first tracking job, which will be pretty convenient. To reconstruct the camera's movement, respectively the witness cam's positions, we have to track some background markers in all 3 cameras. Let's start with the main camera. Quick tip, since it's already clear we do have only markers to track, we can set this tracking mode as a default. Open requester point defaults and set tracking mode to marker. Okay, tracking time, the first of many. Let's create a new tracking point, adjust its tracking area size, gauge marker, finally track. Great, there are plenty of track markers covering the entire sequence. These points now have to be used to track the exact same background markers within both witness cams, to make sure all cameras are placed into the same world space to each other. Otherwise, if some points are just tracked within a single camera, 3D4 has insufficient information to calc the correct 3D position of these points, hence the correct 3D position of our cameras. Luckily, we do have survey data of the green wall and its markers. Having survey, the 3D position of each marker is defined precisely within world space. This gives us the freedom to track whatever background marker suits best in each shot individually. So, let's quickly import survey and assign our track points to it. At first, switch to 3D orientation controls and import OBJ file green screen large from the tutorial folder. Here, we have a beautiful representation of the green wall and its markers. Next, switch to lineup controls. Center the camera on the model. Then use Shift and all 3 mouse buttons to drag it around until the locators of the OBJ roughly match with the markers on the green wall. Looks good enough to start working. Now, select the point and assign it to the vertex of the respective locator. Its type changed to survey. We see the camera is now moving around this single assigned point, which enhances assigning the remaining pretty much. Cool, every point is assigned. As we can see within 3D orientation controls, all tracking points already are placed correctly in 3D space. Back to lineup. Please be aware that at this point of the mocap project, the 3D model will never match perfectly with the markers in the shot, since we didn't adjust lens distortion and focal length at all. That's it for the main camera. Both witness cams are already waiting. But since these cameras are completely locked, just a few points are needed to reconstruct their positions in 3D space. Also remember that we are completely free in the choice which background markers should be tracked, thanks to our nice survey. Great, the markers are tracked and assigned to their respective locators. This already results in roughly correct camera positions, at least in frame 1 due to the lineup. Of course, we are curious, so let's calc all to see the entire camera movement and have a look at the results in lineup controls. Well, a little shaky, but all in all not completely false. Everything else would have been a huge surprise due to the completely unadjusted anamorphic lens, so no problems with the assigned survey points. A quick look on a witness cam. Also good. All 3 deviation values can be ignored at this point, since here as well, not a single lens parameter was adjusted so far. This chapter will be told in part 2 of this tutorial. In this part, We'll now focus on tracking all those markers on the young lady's face. Alright, again, let's start with the main camera. The forehead seems to be a good start, since these markers are clearly visible from the beginning. At first, we need a new point group. All those mocap points cannot be used for any camera reconstruction, therefore have to be in their own point group. So, let's create a new one. Having 2 point groups, to identify them quicker, we should name the old one to Camera and the new to, I think you might guess it, Mocap. As mentioned, we need a mocap point group, so change its type from Object to Mocap. Good, our preparations are already done. Time for tracking. But first, let's have a closer look on these markers, especially at their shape compared to the background markers we tracked previously. We see they are little spheres glued to the actor's face, unless like the flat 2D markers on the wall. What does this mean? Ideally, with a view of needing all 3 cameras to reconstruct their 3D positions precisely, we have to track the sphere's center in every camera. Due to light and shadows, this will be hard since the reflection point of each sphere moves depending on the light. Here are coming image controls into play. So let's add this pane. In this pane, we find the chroma key, which creates a mask for our markers. Separating them from the surrounding background will improve the tracking quality tremendously. Activate chroma key, of course, as well as the controls itself. Then, using button Pick Plus, either from the pane or display area, draw a bit on the white marker to add their color range to the mask. Fine-tune the range a bit. Remove noise from the background. Great, looks clean and nice. Last step is blurring the image a bit to smooth all edges. Now, create a new tracking point on this marker. And of course, adjust its tracking area to the marker's size. Since we quickly notice all markers are sized approximately equally, setting a default tracking area size makes sense and will prevent us from adjusting the area again and again. Finally, gauge marker and track. Tracking looks good so far. The tracking point seems to stay in the marker center all the way down. Disable image controls and check the tracking quality against seeing the original footage. Perfect! Our first mocap point. Yay! One important tip. We are going to have a lot of points in our project. Points which have to be tracked in 3 cameras. So, a well organization is highly advisable. At least unless you have a well-hunting magic memory that can tell exactly where point 1 belongs to and where point 137. No? Then let's do some organizing. Giving points unique and recognizable names is a good start. I'd like to name points according to their positions on the face. So, this will be forehead, center, row 01. If done properly after every point, this can be done in 2 seconds and saves a lot of time later. Great, on to the next point. This time with a slightly different usage of image controls. At first, like previously, with image controls enabled, create a new point. We see the tracking area already fits great. Now, before we start tracking, let's enable Options, Apply Image Controls to Tracking Boxes only. Center it on the marker. Finally, track the point to see the effect. Like the label indicated, image controls only apply to the area of the defined tracking box. Sometimes, just seeing white dots on a black screen can be quite confusing, especially for detecting tracking errors. Enabling this option helps in such situations. Okay, our point behaves nice and smooth so far. Well, until this mobile device hides it. Let's go back a bit and find the last correctly tracked frame. Here we go. And point. Finally, again, naming. A quick check. Perfect. A second tool for organizing are grouping points into point sets. Just select those points we like to group together, right-click, and select Group Points. You might know what will be the name. Exactly. Both points are now in point set Forehead. Alright, there are many points left. Have fun! We did it! At least for the main camera. All markers on the face are tracked, named, and grouped into different point sets. Pretty good job! Next, we have to use the previously tracked points and track their respective markers in the left witness cam. A quick virtual tip. Instead of switching between cameras, it would be nice to have both cameras simultaneously on the screen. So, let's open a second 3D4 main window and place both beside each other. Now we can use our first main window to track points in the witness camera while using the second main window for a double check. Let's start again with the markers on the forehead. As we can see, if a point is selected in one main window, this specific point is also selected automatically within the other. This applies to the selection of cameras and point groups as well. Setting the active camera or point group, on the other hand, is done individually. Perfect behavior for our next steps. Back to the forehead point. Image controls have to be adjusted to match the light conditions within this camera. Okay, default tracking area size has to be set again due to slightly different marker sizes. Very good. Center point. And go. Now, before you spend more hours tracking every single point in both remaining cameras, here's a present from Santa. In 3D's tutorial folder, there's a 3DEqualizer merge project containing the entire setup and all points tracked. In the beginning of part 2, it is shown how to import such a project. But before you hurriedly close this video now and run to part 2, here's one last quick tip. Some points are really tricky and mean to track. No matter how we adjust the tracking area or how much we play with image controls, some points won't stop jumping to neighboring points if they are very close. 3D4 has an option which helps reducing this behavior in many situations. It can guess, or more precisely, extrapolate tracking points more accurate if enough neighbor tracking points are available which are moving similar, like in this case. To enable this feature, let's select Options, Extrapolate Tracking Position, using neighboring points. Let's start from frame 1, delete the previous Terra tracking curve, and go. Much better, right? Of course, this isn't the holy grail in marker tracking, and there still will be points driving us totally crazy, but it really helps in most cases. So that's it with part 1. We imported 3 shots for our main camera and both witness cameras. We synced them properly and tracked all points necessary to reconstruct the cameras and the facial expressions of our actress. In addition, they are exemplary organized. Thanks a lot for watching. I hope you enjoyed this video. See you in part 2.